Hello, welcome dear students. In today's online class, we discuss a few more numericals in solid state. In one previous class, we had discussed some important numericals in solid state. Refer to that. Let us take a few more numericals in this class. The first one, you take down the question. A solid made of two elements P and Q. A solid made of two elements P and Q. Atoms of Q are in CCP arrangement. Atoms of Q are in CCP arrangement, that is FCC. And atoms of P occupy all tetrahedral sites. Atoms of P occupy all tetrahedral sites or tetrahedral voids. The question is, what is the formula of the compound and what is the coordination number of each atom? What is the formula and what is the coordination number of each atom? These are the questions. Okay, so in the question it is given that the compound is made up of two elements P and Q, where Q atoms are in the CCP or FCC arrangement. So from that we can say effective number of Q atoms per unit cell Z is equal to 4. So there are 4 Q atoms in the unit cell. And what about P atoms? In all tetrahedral sites. So how many P atoms? We know that if there are 4 effective number of particles in unit cell, in CCP or FCC arrangement, number of tetrahedral void is double the number of particles. That means if it is 4, there will be 8 tetrahedral voids. I have shown you the position of all these tetrahedral voids, right? It will be behind the 8 corner particles. Each corner particle there will be a tetrahedral void. Anyway, so here Z will be what? 8. That means the compound contains 4 Q atoms and 8 P atoms. So the formula will be then what? P8O4. Sorry, P8Q4. But we know we write the formula in the simplest ratio generally. So 8:4 we can write this is equal to P2Q. So that's the formula of the compound. This is how we do it. Now coming to the coordination number. Based on the occupancy we can easily predict the coordination number. And when there are 2 atoms we should mention coordination number of each atom. So first we have to say what is the coordination number of P. P atoms are in tetrahedral void. That means around 1 P there will be 4 Q atoms. So coordination number of P is 4. Right? And what about Q? Around Q, naturally, there will be double the number of P atoms, that will be 8. Generally, this is an A2B type, then the coordination will be just the double. If this is 4, this will be 8. In the case of AB2 type, we have seen calcium fluoride structure, where it is 8:4. It comes the other way around. Okay, so that's the answer, right? We go to the next one. Question number 2. You can take down the question. 2 ions A plus and B minus, have radius, the ionic radius is given 88, this is 88 picometer, and B minus is 200 picometer respectively. 2 ions A plus and B minus have radii 88 and 200 picometer respectively. In the close packed crystals of the compound AB, predict the coordination number of A plus. So in the compound AB, of course this is an ionic compound, what is the coordination number of A plus? That is asked, right? How we predict the coordination? When you are given the atomic the ionic radius, we know it's based on the radius ratio rule. You may find R plus by R minus. That means RA plus by RB minus is to be calculated. So that will be here 88 by 200. Of course, the unit get cancelled. This is coming to around 0.44. So 0.44 is the radius ratio. Now what we do? We check the radius ratio range and see to which type of void occupancy it belongs. 0.44, which comes between this 0.414 to 0.732 range, and that corresponds to which kind of void occupancy? Octahedral void occupancy, isn't it? Because it is within this range. This is similar to NaCl structure, sodium chloride, where Na plus occupy the octahedral voids formed by the close packing of Cl minus ions. So the question is, what is the coordination number of A plus? A plus is in the octahedral void, so the answer is coordination number of A plus will be what? It will be 6 because it is in the octahedral void. Naturally, coordination number of B minus also will be 6. So it is 6 is to 6. It is NaCl type structure. Right. Now we go to the next question. Next two questions are homeworks. You have to do it. These questions are similar to what we did earlier. I will give the hints. So in the homeworks, the first question you can take down. Calculate the Avogadro number from the following data. You have to calculate Avogadro number using the data given. Density of NaCl, sodium chloride, is the crystal under discussion. It is given to be 2.165 gram per centimeter cube. That is the density of sodium chloride is given. Then distance between Na plus and Cl minus. The distance between Na plus and Cl minus ion is given. Distance between Na plus and Cl minus in the crystal is 281 picometer. This is what is given. We have to calculate Avogadro number using the data. So what is the equation to be used? We know density equation for metallic crystals we did. Here it is ionic crystal, that's the difference. We can use the same formula. What is the equation? Zm by A cube into Na. So to calculate Na, what all we need? Density is needed, that is given. Z. This is sodium chloride crystal, so we know what is Z. Molar mass of NaCl is required. A. Edge length is required, but here it is Na plus Cl minus distance is given. So we have to get A from this data. See, in the sodium chloride crystal, we know if you look at one edge, we can see it is coming like this. That is, if at the two corners we have Cl minus, Na plus is coming at the edge center, right? Because that is octahedral void. So if you take the radius, this is radius of Cl minus, and these are, you have R plus, and this is also R plus, this is R minus. So this is the edge length. What is the relation between edge length A and distance between Na plus and Cl minus? See, this is what is given in the question. Distance between Na plus and Cl minus, radius of the anion plus radius of the cation. So what is A here? It is 2 times that. So it is, as we discussed in the metallic crystal, for here it is 2 into R plus R minus, isn't it? That's the relation between radius of the anion and cation with edge length. This is given, so we can get A using this. Okay, so A is obtained. We can easily calculate Na. So Na is equal to, you will rearrange it and get it. Okay, what about, so what you get A from here? The distance 281 picometer here. So A will be 2 into that. Picometer. Unit you have to take care. Unit should be similar to get cancelled. Here it is gram per centimeter cube. So you may change this into centimeter. So that will get cancelled in the equation. Z. What about Z value? For sodium chloride, what is the effective number of formula units in the unit cell? That we have already learned. Effectively there are 4 NaCl units, so Z equal 4. Then what else is required? Molar mass of sodium chloride you can easily get adding the atomic mass. NaCl, sodium is 23 and chlorine is 35.5. So you get 58.5 gram per mole. So you can work it out. Okay. Now one more question as homework. You have to do it. The second one is, write down KF, potassium fluoride. KF has sodium chloride structure, that is rock salt structure. What is the shortest distance between K plus and F minus? Distance between K plus and F minus is asked. Density or what is the shortest distance between K plus and F minus in KF crystal? Density of KF is given. Density of KF is given as 2.48 gram per centimeter cube. So what you have to find out? You have to find out R plus R minus is to be calculated. Right? KF has NaCl structure. By saying that, you get Z is equal to 4. Right? So you have to get this one. So it is similar to the previous question. Based on the density equation, rho equals Zm by A cube into Na. Basically you have to calculate A first. For which you can take Avogadro constant as a normal standard value. You can use M, molar mass, you have to work out for KF. Z is already obtained. Density is also given. So you get A cube, and A you will get from cube root. Once you get A, as in the previous case, we know that in the case of sodium chloride crystal or crystals of similar structure, what is the relation between A and this one? A is equal to 2 times R plus R minus. So once you get A, you can calculate R plus R minus. Right? So practice these kinds of numericals. Right? That will make your concept very clear. Thank you.